Hello, welcome to Blue Arrow seminar and the gala a little bit later on. It's so cool to have you here online today, and we have lined up a really good program for you. And the idea behind there is that what are the things where actually our whole business line of business could learn something from. So the basic background for all the presentation today is learning. So we have Jukka from Aalto, we have Samarin from Futurice, and Sampo Pasanen from Reaktor. And today in the seminar, feel free to ask questions. You need to be logged into YouTube. And please send a question on the right-hand side, which you can see on the screen today. And we will answer the questions at the end of each talk. So feel free to ask questions, and we are going to answer them in the end of the talks. So the topics today, we are going to talk about software engineering overall. So how things have been progressing from 80s. Jukka is going to talk that. And then we are going to talk about what's the beyond stuff after the buzzwords. So Michael is going to talk that topic. And in the end, Sampo is going to talk about the topic, what we can actually learn in the Finnish industry, agencies and customers from the cases which has been done in the international fields. For instance, in Germany. Jukka, I would like to introduce you for today. So Jukka is in Aalto University. Basically, his job is to make people or students better there. And basically, he knows something about programming because he has got a PhD. So Jukka, welcome.
Okay, thank you for the introduction. Right, so having a PhD makes me an expert or not. But yeah, my talk about, from the 80s to today, I was almost going to rephrase the title to something a bit similar, that from the 80s should we go back to the 80s? And of course, this is slightly a provocative title maybe, but let me elaborate on what I see that we might learn from something from the 80s and 90s today. Now, when I started my life as a programmer, of course, that was the screen that I saw. And many people saw the first time, hilarious 38911 basic bytes free. So you had 38 KB to, do your magic. And that's where life began. Of course, later on, there were some much fancier devices like the Atari that, me and some of the friends, we had these Ataris 520s, which was kind of the top end machines back then. Of course, many people in Finland had rather the Amiga 500s, and of course most people had these. But that was the high end back then. Of course, the commonality to all these platforms is that, at least from today's perspective, but also back then they were rather limited. Or of course, in one sense, because you didn't have anything else. Of course, with an Atari you could do a lot of music things, and the Amiga was supreme in graphical capabilities, and so forth. Had even was it 2 megabytes of main memory, so that was big. But on one hand, it was limited, but there were still people who could do magic in with those platforms. And if you look at what the industry was providing, or the game companies back then of course the demo scene back then was creating magic, if you will, out of those platforms and out of the hardware you had actually. So those were the guys who actually could harness the full potential of the platform. I mean, you can do flashback to the old days, Googling, for example, demo scene and Amiga, and you'll see all these potentially familiar intros and demos that the best and most knowledgeable people could do back then. And if you really consider the platform and the hardware you had back then, these were nothing short of magic. Now back then programming was really about harnessing the full potential of the platform. It was we had much more ideas and skills, or at least some of us had. I'm not saying that I had, but many people had more ideas, more skills, and you really didn't have the performance and capacity to do all that magic. So you really had to be clever when you started. When you wanted to do something really cool and something no one had never seen before. If you consider, for example, the change to today, let's say, from 1990 to today, if you do the math with, using Moore's law, we roughly have 1 million-fold more processing capacity than we had, in 1990. 1 million X, not million percent, but 1 million X. I mean, think about it. Storage, kind of similar. I mean, back, late 80s, 90s, the 1.44 meg floppy was pretty much high-end storage, and nowadays 1 or 2 terabyte of hard drives. That's nothing spectacular today. So give or take a million-fold increase. Also, if you look at the so-called Nielsen's law of internet bandwidth and how that roughly has evolved, so it talks about what is the available high-end connectivity that you have and how that grows. It's slightly less than Moore's law, but it's still a serious growth curve. It's not quite a million-fold increase from 1990 to today, but not very far from that. So everything is has grown tremendously. If you think about any other industry that would have 1 million X increase in performance or capacity in 30 years, that's would be unheard of. When I started as a professor in Aalto back in 2006, that was the high-end smartphone I had back then. Really the high-end Nokias, and nowadays I'm carrying a Huawei Mate 20 Pro in my pocket. Cool enough, if you look at the specs back then, when I started my career, 220 megahertz dual ARM and 64 meg RAM, and now I'm carrying 8 cores worth how many gigahertz, and the amount of RAM I have is 1,000-fold change in how much RAM I have on the device. And even today seems like my device is not always up to the task of the daily activities. Now, if you think about the skills that people had back in the old days, or at least when I started my career as programmer and in computer science, and if you think about the million-fold increase in almost any measure of ICT performance, whether it's storage or bit rate or computing capacity, then you would expect that we have lightning fast services and applications today. I mean, really lightning fast. They boot up in a fraction of a second, and everything happens, faster than the blink of an eye. But do they? I mean, where are these lightning fast things that a million-fold increase in performance would, of course, just looking at the math, would enable us? But still today, it seems that programming is not anymore about the platform. It's not anymore about the performance. It's about potential or capacity of the programmer. Or we might consider that it's actually about the budget. You don't care that much anymore about performance. You don't care about capacity. It's you need to stay within the budget, and you use this offshore and whatever means of getting the cheapest programmer and most lines of code with a certain amount of money. So it's really more about the time and budget nowadays, time to market, and within a certain budget than the absolute performance capacity of the software product you are doing, or whether it's a full-blown system. I have some examples coming. The only exception I could think of, I was really trying hard to think of, is maybe IoT, because in IoT, in many cases, you have these battery-powered, very small devices, so you are kind of forced, which is a good thing, to think about your implementation. Actually, you really need to think about it and not just have a quick brainstorm and then you go and implement and launch the product next week. But actually, you probably need to think even once or twice and how you really do that. Well, let's use the World Wide Web as an example of what I'm getting at. Given the increase in a million-fold increase, you would expect that of course we have websites which load in a fraction of a second, and everything is lightning fast and enjoyable and so forth. Of course, many of you know that that's not true, but let's look at some of the numbers. Just for the fun of it, I was looking. I tried to find what was the browser specs back earlier in my career in Otaniemi, and I could find, for example, Netscape Communicator from 2008. File download size 5.78 megabytes. It needs 64 megs of RAM and a Pentium processor. That's your web browser 2008. Anyone who understands about software today kind of realize that your browser today will not run on 64 megs of RAM. It will not run on a single 200 megahertz processor, and it will not be satisfied with 50 meg of hard drive space. I couldn't find really the specs. I was looking at my Mac, and that one says that the Google Chrome, after I clear all the caches, uses about 454 megs of storage. I mean, it's a web browser. Same as behind that, the Netscape Communicator, which was 578 meg download and maybe 10-20 megs on the hard disk. So that's your web browser today, which is kind of insane, but that's another story. If you look at for example, from HTTP archive, you look at the evolution of web pages, then that's the median. If you look at the median desktop page size in the last 9 to 10 years, that has roughly grown by 300%. But look at the mobile web page. The growth is about 1,000%. 1,000%, tenfold increase in the size. And if you look at the comparison, I've been naive in the past that I was thinking that mobile web page means that it's a lighter version and lighter version for mobile devices, but that's mumbo jumbo. Mobile website is nowhere lighter than a desktop version, which is kind of sad if you think about it. Then if you look at the time to load, so looking at the onload event on the browser, median desktop, if you consider the 100x increase in 10 years of computing, storage, network speeds and stuff, then that hasn't changed pretty much at all. It's still roughly in the 6 second range, the desktop. Partly because the web pages are so bloated and the whole World Wide Web is pretty much screwed up currently. But if you look at the mobile web page, then that has grown by 400%. At least based on these statistics, the median is almost 20 seconds, which is kind of sad if you look at it. So that's where the technology is considering what the electrical engineers have been able to do in 10 years or 20 years. Is the answer nowadays that if the service is slow or the app is not working, your hardware is a problem? It's not the software that is the problem, it's the hardware. So you just go and buy more and better hardware. You need a faster network, you need better, more storage, you need better processor and so forth, whether it's your mobile, whether it's your laptop, and so forth, potentially the TVs and stuff today also. So kind of the problem that I've shown, or the growth of everything, despite the increase in electrical engineering and the hardware performance, then the answer today is just, buy better hardware. It's your problem, not the software problem. So I would almost claim that the whole software industry is pretty much eating all the benefits that the electrical engineering field has been created over the past, I don't know, 30, 40 years. So whenever, electrical engineers are able to build, better processors, faster networks, more storage, then the software industry is pretty much eating everything up. And back to the drawing board of figuring out how you can do it even faster and even, better in the future because of software. I mean, the hardware is nothing without software. And the hardware is only used to build services, provide software to build these services. So of course you could ask, why? Why are we in this situation? And it depends on who you are asking. Of course, you can claim the customer, you can claim the, companies, you can claim the, universities, pick your choice. But in general, you could see the software engineering as doing pretty much the same as any other industry has done in the history of this planet. I mean, car industry is an easy analogy here to use. If you think about it, cars, back 100 years ago, cars were new. The whole industry was thinking about how to manufacture them, and the Ford was building the first, full lines of, building cars quickly. You were thinking about the engines, all these, ownership and models and stuff like that, and that has been going for, it went almost 100 years until, last maybe 20 years, the talk has been much more into resource efficiency. People know how to manufacture cars. Now the question starts to be, how do you make them resource efficient, whether it's in terms of materials or whether in terms of, burning fuels or going into these, hybrids and electric cars. So the car industry nowadays is much more focused on resource efficiency, and that is the mantra that they are advocating. It's not really, growth and, more and more and more. So in a way, you could ask whether the ICT industry is still in this, early phase of the car industry, that, more cars and cheaper cars, so more software, more code, more lines of code, and, trying to make it as cheap as possible, so you win bids and you get this, done in, within a certain budget without really caring how much, resources they consume, whether it's, cars with the gas or whether it's electricity and hardware performance. You might ask the question whether the problem in the ICT is that the buyers are not educated enough to demand more. If you think about the car industry nowadays, then buyers really know what they want. And if you try to sell in Finland a 3-liter gas engine, then good luck selling that, because no one buys that anymore. And of course, that was a downfall of the whole US car industry, because selling these 3, 4, 5-liter gas engines wasn't something that Europeans or Japan and so forth wanted anymore to buy. And they figured that one too late, and of course had to change everything. So of course, the question is both on the consumer side. If you go back to whether it's car industry or ICT, both, it's both a consumer question and the corporations or governments who are having these bids for companies to build certain services and build apps and so forth. Then are you really understanding what you are bidding, what you are having the bid for? What are your requirements? And people are offering, solutions and services and doing them within a certain budget. But are you getting just crap out of it? It's within budget, but you are getting crap, and then you are screwed because you need to, buy a full data center again to run a new service. Same for consumers. You don't really see consumers having understanding how these energy performance, issues, and you can't really make a decision that, hey, I will download this game because it uses, less processing power and less storage, for example. You don't really see that happening. Maybe in the future. Now, if you come back to the university question, of course, me as a professor at Aalto, then of course education follows typically the needs of the industry. We have a constant, dialogue with the industry and understand what type of experts the industry needs and wants to hire. Of course, we need to keep our own mind that's in certain places, and in certain places, of course, we need to make sure that the Finnish industry and the Finnish software and ICT industry is getting the high quality experts from the universities that they need to maintain their competitive edge on the global scale. Now, if you look at, for example, programming education, back when I started programming, or if you think about how you used the old platforms, and of course assembler was the way to get the performance out. Of course, there was, when I studied at the University of Helsinki in computer science, there was Pascal. I don't remember, did we have Fortran, but at least we had Pascal and stuff. And then I guess there might be some version of BASIC back then. Then the teaching went to C, and we could do on one hand higher level things, but on the one hand, when you were able to do low level programming, you could actually affect the performance of the applications. And we had a lot of teaching and thinking, especially related to network applications, how you actually how you can screw them up and how you can make them efficient. Then the teaching actually moved, or if you think about the first language that students were learning, then that actually moved to Java. Then at some point it was deemed that Java might be, still too complicated, and actually the first language seems to be Python nowadays, and I don't know if JavaScript is also there and so forth. So if you look at the kind of change, it has really moved from a very low level abstraction. You could also do count the number of libraries available in that programming language. So it has really gone from a very low level abstraction to a very high level. Programmers don't anymore see or know, understand the platform. They just write code, and more is better. Then, of course, in terms of course code per hour, that is totally different. Then, of course, with assembler, you could write a lot of lines of code, but not get much happening on the screen. And with Python, you can write a few lines of code and get stuff happening on the screen already. So I didn't use lines of code here, but some kind of functionality per hour. Then, of course, that has increased when you take the abstraction level higher. That just also ran when I was doing my background research for this. It was an interesting statistic from Indeed on the average salary and job openings this January in the US. Then you can see that actually Python programmers are the #1 sought resource, which is kind of interesting. And then Java, JavaScript, and my favorite language C is only at the level 6th. And even salary expectations then for C programmers, which I do appreciate, then actually their salary expectation is lower than Python programmers. So that is what the industry is looking for. You can find similar statistics, like this was the programming language popularity from GitHub, and there you can also see that the most popular language seems to be Python, and then Java, JavaScript, C#, PHP, and my C language is again, low on the list. Of course, you might ask the question: so what is the role of programming languages? Potentially, all these, different frameworks. If you build a web application, you have probably 100 different frameworks you can choose from, and they get the new framework every month, and which is again better on whatever metrics than the previous ones. And of course, skills and so forth. So what is that role? I don't have an answer for it, but I'm just raising the question. So summarizing and going to the end of my talk, I'm asking the question: is ICT on its road to become the next environmental problem, or is actually software becoming the next problem? Because hardware performance increases by 100-fold every 10 years, or at least Moore's law brings 100-fold increase in performance every 10 years, then why is that performance not seen in the services? And everything is slow, everything eats up even more, and all the AIs and stuff like that. I mean, you have more AI concepts available and potential than there is processing power on this planet. So what I'm asking and what I'm kind of advocating is, could software engineering become again resource efficient? could you start doing, things that where you need less? So kind of less is more, from the perspective that my application needs only this and this much of network storage, or processing power, or even bitrate from the network. I've seen many cases where you can build the same service, and we even have a research paper wrote back in the days when we're just looking at how many clients you can serve a video stream with certain hardware and certain software, and there was a huge differences just by picking the right software or configuring a software and looking at the different hardwares. So kind of as a last slide, I'm asking whether we should go back to the 80s and go back to thinking about programming also from the hardware performance and output perspective, and think about what is needed to run my service, instead of whether it's in budget and how cool the UIs are, because with cool UIs you can hide the rotten core, if you will. But that's the end of my talk. I'm happy to take questions.
All right. There is one question. Can you hear the question, right, Jukka?
Yeah.
Okay.
Only
cool.
one.
So yeah, there is for now there is one. There will be more.
Yeah.
My Amiga 4000 booted in 3 seconds in 94. My Mac boots in 20 seconds. Why are we wasting our time waiting our blown out systems instead of having lightning fast experience? What could be done to do that?
Sorry, so there was something about booting up and...
Yeah, so in a nutshell, Amiga 4000 booted in 3 seconds in 94. And then the MacBook boots in 20 seconds now. So
with an SSD drive.
Yes. So what could be done to fix that?
Well, actually this is my message on this last slide, that software engineering today, and partly because the customers don't understand what they are, for example, buying. Then software, in my opinion, of course, I'm exaggerating. There are use cases where you have the opposite, but in the big picture, there is not enough focus in programming and software engineering today to think about how resource efficient my software or service is.
So
in the big picture, that is the problem, and that's where whether it's it's companies, but it's also customers need to understand how you order, for example, systems. And for example, let's say government orders a new big service platform. Then the question is how many servers you need to run that, and that is a factor in evaluating the bids. If someone says 100 servers and someone says a data center and someone says, well, we can run it with one server.
So do you think the background reason is that it is actually cheaper to buy more hardware than to do kind of energy efficient programming?
Well, the cost is on the customer. And that is actually it might be that actually it's cheaper for the end customer if you pay more for the software and they need to buy less hardware. That is actually a very valid point, and actually it would be an interesting research question that, let's say, if you pay 50% more for your software, and then you need 50% less hardware, or need only 10% of the hardware that you would have needed otherwise, then would that make actually a good deal?
That's an interesting point. There's one final question. And it's about what the whole industry should learn from the findings you have made. How the tomorrow should be different?
Well, I don't know if my slides are still very visible, but the second to last slide I had is the less is more. Who has the kind of strength and courage to take the step in discussing and having the notion of performance in the software, in the bids, in the offers, And because when someone starts doing that, like, let's say, Toyota Prius was launched in '97, and of course it took a long time before every company now has hybrids, and some people go all the way only hybrid cars.
Yeah, yeah.
Then when some people start having that and advocating that, hey, we do premium code, we do premium software from the hardware performance, and you need less servers to run our solution, then that is when everybody else needs to do that, the same thing.
Okay, so basically, in a nutshell, that we want to have the greener software industry tomorrow. Jukka, it was so great to have you here. And if there are any other comments, please ask in Twitter. It's Blue Arrow Awards. You can see it in the screen now. And now I would like to introduce our next speaker. So I just want to show the pictures briefly. So Michael Samarin from Futurice, it's going to talk about stuff. What's their background of the buzzwords? So what are all the nice things? What the industry has been talking a lot? What are the nice things? What the customers are talking? So what's really the story behind those? Welcome, Michael.
Thank you. Hello, and thanks for inviting me.
Yeah, that's really cool to have you here.
Yes, thank you. Okay, so what I wanted to share for this seminar is how to take beyond the buzzwords, the technology adoption. And today I would like to bring 3 examples regarding DevOps, data, and AI that we hear in our industry pretty much all the time. And I would like to bring 3 examples from some of our clients and maybe a little bit inspire you that even the smallest steps and very holistic and pragmatic approach to how you're starting to adopt a specific technology or even the methods or even how do you approach those, these can lead, all of those can lead to different kind of gains and achievements. And as the being an international company, we have opportunity to learn from clients from different countries and to see how the technology adoption and digitalization is going through clients in different countries. And what is interesting is that here in Finland, we are actually in a pretty solid space, and we see how the digitalization through the society, through our public services, and through our clients is actually on a pretty good level. That said, there is so much that we can learn and understand from each other and from how different companies are taking the next step. And technology specifically, of course, and that resonates extremely well with the Jukka, with the previous talk. It requires a budget, it requires money, it requires scale, and traditionally, from some of the estimates, what we see, the horrible picture when we're concentrating only on the adopting specific technology without thinking of the consequences and how effective it can be or how it can have an actual real impact for our services. What we can see is that sometimes up to a half of our R&D budget is essentially either waste or duplication. And this is a horrible statistics, and that's sometimes this is a best case scenario. And what I would like to do is I would like to actually bring one historical lesson from the 80s again, that even so we are hoping that there is a magical silver bullet of the specific technology or a specific approach which can move us significantly beyond our competition or deliver better services. The fact is, there is no silver bullet. And I would like to bring the very famous article of the Fred Brooks, who also a famous author of the mythical Man Months, which was published in Computer Magazine in '87. essence and accidents of software engineering, which is essentially known as no silver bullet. And despite the fact that the article is more than 30 years old and it's been challenged multiple times, the main idea, in my opinion at least, still very relevant. And the idea is that software is incredibly complex. And this is the essence of the software. And why is it's so complex? Because essentially software is abstraction of our mind. It's an abstract that we're trying to channel and interface into the physical world. And of course, that's going to be a problem. And I would like to encourage us and the companies to look at this actually from the complexity problem. And if we would approach how we would solve specific problem from the complexity, then we would also understand and encourage ourselves to perceive the problem and the solutions from this side. For example, that like a simple problems, they require simple solutions, and the complex problem, they actually require a complex solutions. And if you look at these two pictures, that essentially it is exactly the same thing. So we are hitting one thing with another. Only on the one side, it's a hadron collider, it's a particle accelerator, and on the other side, it's a hammer and a nail. So essentially, they're doing one thing, like hitting one thing with another, but the complexity and everything that is involved is completely different. And what we've been observing is that the technical teams, they do have a tendency to overcomplicate the solutions, and the business team and management teams, they have a tendency to oversimplify the problems. And how to find this common ground, that's the problem, and that's how we are trying to learn from each other and see what kind of approaches can lead to better results. And of course, it means that we are being bombarded nowadays with all kinds of buzzwords. And if you are a modern technological leader in the modern corporation, you are bombarded with this all the time. And today, as I mentioned, I would like to stop on three buzzwords: DevOps, data, and AI, and take them one by one and bring you a very interesting, very simple and inspiring example from our clients. And let's first talk about DevOps, which is traditionally nowadays is understood as the development and IT operations are working continuously together. But the interesting fact, if you look at the traditional functional silos of our organizations, and especially the large corporations, that we see functional silos. And this whole process when we are actually delivering IT solutions is mapping those functional silos to the traditional functional approach, where we have a specific teams, analysts, architects, development, Q&A, quality assurance, etc., etc., etc. And this leads to the situation that previous speaker was also bringing up, that if we look only from the cost perspective, and even if we deliver specific solution in time, scope, and budget, we consider it as a success, even though it's exceptionally rare to do so. But there is so much beyond that, and we can't really look only at the scope, budget, because what is, unfortunately, it leads to the following situation where the development team or a delivery team is creating the solution and then handed it over to continuous maintenance, etc., etc. And this is a reflection of these functional silos that we are observing in organizations when there is a continuous handover and handover and handover. And it leads, of course, to the difficulties in maintenance, technological debt that is being created under the pressure, and the people are allocated to too many projects. So what is the solution is in here. And when we start to holistically apply the DevOps and then trying to bring the understanding that the code becomes legacy, essentially, when it hits production. Once you're starting to understand that, then the switch is being done, that it means that we have to be in a continuous mode all the time. And the software, it's actually not a product, the software, it's a process. And if we look to the a bigger picture, we are starting to realize that organization, not the software, but organization is the problem that we are trying to solve. And with that, if we look traditionally at DevOps as a development IT operations, we actually have to add one more component there, which is crucial. And without this component, nothing is going to happen. And this is an organizational change which allows, infuses, and encourages the development and IT operations linked through the business, linked through the real usage, linked through all kinds of metrics to create this continuum that is working all the time. And I would like to share with you one anecdote or urban legend that I've heard some time ago, that in the history of one of the largest cities in the world, in the history of existence of the subway system or the metro underground, there was not even a single day when it was not maintained. Just think about that. That's reflection of the physical world. And how we can then think about our software, which is once created and shipped, and then it goes into the maintenance and then goes back to development, maintenance. That's how we should move forward. That's how we're supposed to approach our holistic view of the DevOps. And I would like to share with you a story of one of our clients where we have created together the DevOps team, where all of these components are working in parallel simultaneously, and that's Finavia. And of course, we have to think back at the normal operations of Helsinki Airport, for example, where the single very small team creates and continuously maintains across several years the very large part of the consumer-facing services. Those are the parking reservation systems, those are websites, those are indoor navigations, etc., etc., etc. And that's the entire team that we are talking, where there are few roles, including everything, and the most important part where the business and product owners are essential part of the team. And it leads to the situation where we have a continuous mode and priority-driven scope, where essentially team is actually pulling the tasks from the priorities lists, which are created together with the business, understanding implication that are going to be on a system. And the entire process of how those are floating or flowing from one part from one mode to another is the essence of this. And the interesting part is that the entire team is running like 10 to 15 projects in parallel without stress. And there is even another short controversial anecdote where a team at one point have a goal that it would be okay to create a deployment on a Friday evening and be safe and go home, because the entire infrastructure, in case of emergencies, will roll back and restore every potential fault. Of course, this is like a goal, but that's like how it is. And another critical components where essentially every member of the team is interchangeable within the team. So the team is trying to understand and get and change the roles inside and continuously be within the team, so that the knowledge is in the team and in the organization and not in the individuals. And I would like to also mention that Finavia and the Helsinki Airport is actually a multi-award winner. And if you would like to know more about the whole array of technologies and everything that was used and still used in the project. So you can actually have a very interesting long form article to read about this project. And then if we move forward to the next buzzword, then let's talk about AI. And the interesting part is that at the same time, you can hear AI and artificial intelligence and all kinds of intelligence systems being applied pretty much everywhere. But at the same time, when you start looking at your own business, you are at the same time kind of puzzled. What's in it for me? How I can actually, instead of having a major IT spending and buying something or trying to create a system, intelligent system, to solve a specific problem. And if we take a look back, that traditionally, if we have a problem in a software development, in a programming, we are looking at the essentially if then else. But what happens if we have a data in our problem which is very complex? And that's very interesting. So one way to scale and to solve the problem is, of course, to create extremely complex logic. But if we look into the history, so the idea was, what is there a system which is actually being able to solve this without creating the logic? So if we do have a set of data, and we have samples, and we know the potential inputs and outputs, can we actually train the system? Of course we can. And of course, in the 50s and the 60s, and even in the 40s, the idea was that if we peek into how our neural system is actually working, then maybe we can correlate and create mathematical models and simulate that and to take this part of the training. And that's where the AI is coming into the picture, where we can say that the neuron is a mathematical function that takes some inputs, and based on specific algorithms, it produces some output. And that's the whole entire field of artificial intelligence and the neural networks was born, where we can not only the train system on the samples of data, but also we can do the generalization of the data and feature extractions. And also we can essentially create the data that didn't exist in the original data sets. And today we see multiple applications of that in every aspect of our life, in terms of prediction, personalization, etc., etc., etc. However, how we are able to apply that in our everyday business, when you are working in an organization and you're trying to take something from that and start applying in your business. And that's, of course, you need data. And that's where the problem starts. That in the modern organization, unfortunately, what we observing, there is no so clear data governance, there are no clear data maintenance. And essentially, before moving to intelligent solution, you should get your data in order. And unfortunately, what we see, especially from the management perspective, that like a short-term benefit of using, let's get another Excel, versus the long-term understanding how the data should flow through your organization and how you expose it in the critical components in order to make certain decisions, or in order to being able to apply some intelligent solution. So the data governance, data maintenance, data accessibility, and transparency, these are the 4 components that we encourage the organization to look at before they are starting to consider applying specific intelligent solution. And what's interesting, when you are starting to aggregate and make this data available for certain specific decision-making scenarios, then you're starting to see benefits even before applying intelligent solutions. And I would like to bring one of our clients, Fira, which is not only a construction company, but it's also a technological company. And when you are moving everything from being data not transparent to a data which allows to aggregate and consolidate data from the specific construction websites and to see, can we actually predict and or can we detect construction projects with potential problems before? And then once we are starting to aggregate the data and look at the so-called magical proxies, how we can predict, for example, or make a decision if the specific site is potentially encountering problems based on not direct set of data. For example, we can look at the access controls, how people are moving through the construction sites, how long they're waiting for the supplies, etc., etc., etc. And essentially, what FIRA did, they started to aggregate the data into the multiple dashboards, which can oversee entire construction site or multitude of sites. And that led to dedicated centers where you can actually see what's happening with the data, and you can see and expose potential problems early on. And that's not even trying to apply some intelligent solutions, but just to organize your data, expose it to the needed decision makers, make it live and making it real time. And the FIRA today is leading actually industry also into moving certain parts from the construction site into the prefabrication, which can be done in a much more efficient way, and then move it back to the construction site. So essentially, FIRA is leading the systematic change in the construction with the potential profit improvements, which are in the industry with the pretty much zero annual growth. And looking at the taking from the cost mindset to the flow mindset and expose the data to the needed decision makers from the opaque to the transparency. But once you actually do have data in order, then can we start applying certain intelligent algorithms? And that's what happens with our next client. Let's take a look at the weather. So we live in Finland and we're all familiar with this type of weather patterns. And what we're observing that the weather patterns are becoming more and more severe. And that affects a lot the business of one of our clients. Because whenever there is a severe weather patterns, we have power outages, we have wiring breaks. And this client is Elenia, where it's their day-to-day business to deal with the consequences of the severe weather patterns. And the phase number one and the first approach is to understand where we have to ship the maintenance team and maintenance crews and repair teams to actually start repairing the electricity power lines breakage first, because there are very few crews always. So, and it's not continuously expanded resource. And there's like a gigantic territories where it needs emergency service. And the step number one is actually was to, again, consolidate and take all the potentially available data, which in the old times used to be in the separate Excels, accessible only to a few people, to consolidate into the very specific UI, which actually illustrates in a role-based manner. So to the teams who do have a specific need to look at the specific area and make a specific decision, how we can represent the entire area of the country and potential severity of the problems. So this is step number one, consolidation of the data, bringing it to the control center, make it transparent for the teams that are making decision. And then once this done, the step number two or a phase number two, because there is a huge amount of historical data with the power lines, with the outages and with the weather patterns. can we actually look at all of this massive amount of data that we have and start predicting what kind of a weather patterns can affect which kind of areas? So it's possible to, for example, pre-deploy teams in advance and to have a prediction, and essentially this the result of the applying this approach from the first data transparency, consolidation, and bringing it to the single place, and then to using this data in order to make a predictable predictions, and which are ranging from few hours to actually a couple of days time. And then once we have this, we can, as I mentioned, pre-dispatch the teams. We know potentially which areas will be affected first, and we can combine it in the control centers with the observation on the ground. For example, something that weather patterns are not telling you, that if, for example, the ground is frozen, the trees are less likely to fall, or the other way around, if there are still a lot of leaves on the trees, then those are most likely to fall down on the power lines, etc., etc. And what is another interesting consequence is that because all of this is being recorded, so it means that the teams can actually train and replay different scenarios that happened in reality in the past and optimize then already on the human non-algorithmic levels of what kind of a response could be driven first. So this is a picture actually from the real control center where this system is running and implementing. The Elenia published actually 2 papers based on these 2 approaches in the efficient coordination a few years ago, based on the exposing, aggregating the data, and the second part in attempts to predict the impact of the weather patterns on the outages. So as you can see, the 3 common buzzwords that we hear today, DevOps, data, and the AI or intelligent system with the prediction, and the very, very small and pragmatic steps into the approach, how we can take those forward. So concluding, I would like to emphasize that please remember, as much, this is our human nature, we would like to have a universal solution that is applicable everywhere, but there is really no silver bullet. We can just like learn from how we are applying something in different scenarios and make our own decisions based on that. The organizational change is one of the major impactful areas where you can make like a really significant change. So software and technology is actually rarely a problem. In many cases, that's mostly organizational change. Shifting the mindset from the observing the costs only to actually to the flow mindset, how entire operation is working, touching every part of the organizations, and the most important, touching the end clients and users of your solution or of your product, that get your data in order before trying to apply the like intelligent approaches, and first and foremost, small pragmatic practical steps and experimentation. That's how the success is moving forward. Thank you very much. If you're interested with some more technical details behind some of those solutions, there is a longer version of my talk that I did a couple of months ago at the Microsoft Tech Days here in Helsinki. And thank you very much. And let's hand it over.
Thank you, Michael. There's a couple of questions. One question is that when will AI replace software developer?
I don't think it will happen. And of course, what we are interested in, essentially the codeless solutions. So there is a very old saying in the computer science, let's program to write programs. So that's the way we would like it to be. And that's where essentially a lot of effort is going into. But to be honest, I don't see it, at least on my lifetime, where it will happen that create me this type of a product, and boom, magically it appears.
So there's actually a continuing question. So if you think that the software developer will be a big thing in the future as well, what would be the skills which would be taught in the universities now?
It's it's a very good question, and also spent considerable amount of time in academia before moving to the business. What I can say is that from one hand, of course, at universities and education, we would like to teach and learn a very practical skill set, which we can almost immediately use in our professional life. At the same time, it seems like, and what we've been observing, and what, for example, Jukka was also saying, is that sometimes it means that unfortunately we are dropping off the fundamental knowledge of the systems at large. Everything depends on everything, and the communication is the key, etc., etc., etc. That it's impossible to have, like a single solution, that you have to consider multiple things, and you have to look into the fundamental areas of the science and how we approach the problems. So combining these two, the pragmatic approach and at the same time the fundamental knowledge. So this is a challenge. And that's, I believe, where we should move into.
All right. So then there's actually one more. What is the best way to sell AI for organizations?
You shouldn't sell a technical. Of course, I mean, I understand. Yes, especially if you are a company which is developing certain intelligent solution, but I don't think you should ever attempt to sell the solution. Or the specific, silver bullet, because it sounds a little bit like a silver bullet. You should first understand always what problem we are trying to solve. And then after that, be brave enough, if you see that there is absolutely no point of having an intelligent solution there, to say you don't actually need this. Or actually finding the opportunity and saying that in here, you can actually reduce this and that resource and make it so much more efficient if you apply here intelligent solution that can be pre-trained on your existing data, etc., etc., etc. So that's, I think, how it should be, and that's, I think, the best projects that we run in Futurice across thousands of projects and many years are actually starting from the problem. What are we trying to solve here? Instead of let's sell the solution.
All right. Thank you very much. Thank you, Michael. It was so great to have you here. It was great talk. Thank you very much. And next one is going to be Sampo Pasanen from Reaktor. And again, we actually got some really good questions already, so feel free to ask those in the live chat. And Sampo is going to talk about international stuff. So basically, we are very often interested in what the whole industry could learn from the projects which have been done by Finnish companies but abroad. So Sampo, I would like welcome you next to the stage. It's really cool to have you here. I'm really eager to hear what kind of topics you have in mind about this international aspect.
Excellent, thank you, Antti. Super excited to be here. I have some learnings that I want to bring to you regarding digitalization in large B2C companies that we work with, and what can we learn from them. And it's been an exciting journey. I hope that I can share some ideas to all of you today. If we start from the kind of the number one point that I think is fundamental for a company's success, is that how strategic do you see that the digitalization is? And the best companies that we work with are investing heavily in digitalization. They talk about it. And I would like to raise a point or one example from Kasper Rorsted, from CEO of Adidas, who stated clearly that our single most important store in the world is our .com store. There is no comparison. there is no comparison. I mean that this is a statement to the company where the CEO says that this is the thing and this is the future. The point of cards is not to undermine the relevance of everything else, but it's to highlight the fact that the online store has become their most important store, and this sends the message to the company that these are the areas where we need to invest in. These are becoming even more and more important, and that sets the tone to the whole company. It's not like the online store or digitalization is an afterthought in the business in itself. It's becoming the business itself, and that's kind of the fundamental understanding when you realize that our company is becoming different, and that needs to change. And that's we are getting the Corona time intervention here. Just a second. Okay, trying to handle the situation here. So this is clearly the time. Maybe I will give the Pokemon time that we can continue with the speech. 1 second. Ota vaan. Yläkerrassa mun kirjahyllyssä. Okay. I tried to solve this by giving him the iPad and a movie already before starting the speech, but apparently that was not equal to Pokemon Go. So at least some people have realized the importance of digitalization in the world. Okay, so the point that I was trying to make is that leaders of the best companies that are competing in the international markets are seeing the transition to digital. They are embracing it. They are communicating about it, and we can see that it affects not only the stores, but it affects how you train people, what kind of competencies do you need to have in the organization. It affects your logistics, the technical solutions, and you try to build these end-to-end streams that are actually geared to the current online world, and that's a huge change for companies. And siellä sen huivin sisällä, siellä pienessä. Apparently very challenging home situation at the moment. So companies are fundamentally gearing towards the transition, and that's we can see this not only at in our customers, but also in the competitive landscape. And if you look at Sweden, they invest heavily on digitalization. They invest way more than Finnish companies do. Even if you look at the percentages of their investments, it's not generic. There are companies in the world, of course, that are lagging behind and companies that are leading, but we can see that some companies are really taking the advantage and that they want to be leading the transition in their own domain, and then grasping kind of the market share that is currently available to grasp. If we take a look at, for example, from the Finland's perspective, there is Mehiläinen, which has first transformed themselves. They are building services and their own processes that fulfill or deliver digital services to current customers, but it's not only there that they've stopped. They are seeing the opportunity to become more international. One of their approaches to internationalization is through digital services that they are selling, and this is super interesting development of in a company's life, and that's that's something that tells a lot about how strongly they see the digital, not only in improving their own operations, but also as an opportunity to grow and to lift the value of the whole company. So digitalization is strategic. The second point that I want to make is that design plays a significant role in B2C companies. The tech part that we are super good at, that's something that you can really differentiate with. You can that's the technology that helps you to it helps you to differentiate in the market, because we Finnish people, we know tech. We have seen that in a number of cases at our customers, and it's something that differentiates Finns in general. But to get to play there, you have to be on par with the design. So it's got to be in mint condition. And if you are not able to meet the requirements in the design, then you are not entering the game. So if you look at, for example, the companies that are seeing things hugely visual, 1 second, I'll try to fix the problem at home. Because when I get to fix this, it's a bit easier to concentrate on giving a speech. I had an awful morning this morning. When I woke up, my kid had hurt his knee, and he had to stay home. And this is, of course, one example in these Corona times when things don't go as planned, and then you have to figure out your way. And I thought that I had it handled, but apparently the movie that I had selected was not as good as he wanted. Let's see if he now have found the phone, and we can continue with the show. I'm really sorry about this. So design, and by design I mean especially the visual aspects of it, and I'm coming down to that later. When you're talking about companies that produce content, where content is the main product that they have, then typically the visualization is playing a major part, and being able to meet that level in your work is something that gives you the access to the game itself. The companies expect that things are visual and working in all of the services that they are building. The expectation levels for visualization in digitalization has risen highly, and of course a person who has a tech background like me would have liked to have code solve all the problems, but we are. It's becoming totally clear that if you are not up to par with the design, then you are not even playing the tech game at all. Then if you come to brands, it's not so much about it's not only about the visuals, and but it's very much about how you fulfill the brand promise also on your digital services. And I think that Jukka brought out a super important point in his speech regarding the use of resources and computing power, and how sleek and fast are the services that you develop. And I think that the interesting point here is that it actually does matter. And if you look at the load speeds of online sites, many of them are not up to par, and it's clear when you have high volumes that being able to reduce the loading times of pages of the site and everything, it increases user retention and it increases conversion rates. So the users are actually choosing services that fulfill the kind of the expectations also on the speed and experience. And I think that these types of things become even more important when you're talking about economies of scale, and I'll be coming back to that later. But so design, as in visual aspects, is a key to entering the game. But then it comes down to delivering the experience, which is up to the user experience, meaning how logical the site is, how easy it is to use. And then and that also comes down to technology, how fast it is, how reliable it is. Does it feel like familiar? Is it easy and smooth? And then when you have that combination, then you are seeing the numbers that these types of companies see when they are launching improvements to their sites. So design is kind of a key to enter the game, and I think that this is kind of a message for both the consultancies like us who work with these type of companies, but also to Finnish companies that want to excel in of course also in the Finnish market, but especially when you are internationalizing and trying to win the hearts and minds of people in general, and this is a distinction where we can see that Finland has to learn from other countries. My third point is economies of scale, and I mean this actually in two ways. I mean that when you have huge user volumes, it can be a question of both user acquisition, the sales conversions, it's the ability to increase revenues, so to say, but it's also a cost question. So when you are launching a new service or a new content to a huge potential audience, and you know that it's going to peak a lot, then you are suddenly dealing with needs to rapidly scale hundreds or thousands of servers, and then because scaling to that size is extremely expensive, you need to be able to downscale that also, and building these types of resource scaling automations to sites and services where you have a wide variation of the user base and the load becomes essential, and this is something that is different from sites where you have smaller volumes and where you're selling smaller amount of items versus the sites where you have huge volumes, because for smaller sites it might not make any sense to hone the last bits and pieces of performance and experience, because it might not be the ROI would not be there. But if you are looking at these volumes where there are huge amounts of users, then suddenly all those single percentages become meaningful, and that's something that you need to take into consideration. So to starting to wrap this up, digitalization is strategic. So it's not. It changes you. It's you have to start thinking about your business also from the perspective of how do we look like when we are thinking of digital first, and it changes how you what you talk about in the leadership team meetings. It changes how you train your people, because it's not enough that leaders see the value. You have to have the capabilities of the business owners, product owners, the teams, and to set that up is challenging. That's the resource that we are lacking in the world, and that's one core element of seeing the digitalization as strategic. That how do I build the capabilities of my organization? Second point was design. It can't be an afterthought. It has to be on par with the tech, and economies of scale for large organizations, where and large sites where you have high volumes, and there you have to start thinking differently on how you build your services, because honing the last mile of the experience is a major boost for profitability and revenue growth. So starting to wrap this up, there was a minor unexpected event, and I have to figure out even more engaging ways to make sure that when you have to give a speech to millions of users like you there, that the potential disturbances have engaging stuff to consume, and that's maybe my takeaway from this speech. Lastly, I want to say that digitalization is people business. As Jukka and Michael talked about, the software is complex and the IT is complex, and you need to be able to communicate the importance of the changes that you are proposing and the approaches that you are taking, and most of the work is about creating the mutual understanding that what we are trying to achieve, and then finding the best way there. And then when you have super talented engineers and people implementing and designing the solutions, then you are on a winning streak. Thank you very much.
Thank you very much, Sampo. And I think this small visit just made the presentation more human-like. I believe we all have had this situation in our life. So this is kind of a COVID time presentation.
I've never prepared this much for a COVID time talk, and still apparently not nailing it well enough yet.
I think that's perfect. There are a couple of questions, and the first one is, yes, when we are in the international field, and especially the case Adidas, the Adidas.com is a huge brand already, and in many Finnish companies, their brands are not that huge. So what do you think about kind of marketplaces for selling stuff? Not from the one brand, but from the many brands. Do you see any chances for Finnish business there?
I definitely see a chance. I think that it's fundamentally about the type of products that you are selling. So if your products are unique, then you should just find and utilize all the channels that you have to distribute that. And I think that some companies could even, if you are totally like product oriented, you could even think of opportunities of selling purely through marketplaces. And I think that these types of decisions are super important. The main questions, I think that if you consider, should I build my own marketplace to sell my products, or should I use the existing ones? I think it's very much comes to the nature of your product, that if you have a super strong brand, then can you be represented in the digital realm in the same way as you expect from the brand. So if you sell through Amazon, you will not be able to get the level of experience that you might want in some environments. And I think that this is something to consider. And then and then so this is exactly my point, in that companies are in very different types of stages, and for some it could be just, just take Shopify and put it on, and it's not that huge project, and you have a working online store, and that's perfectly fine. But then when you start scaling, and when you start finding these scaling opportunities, then it's a question of am I gonna start building the marketplace and improving that, and or utilizing the existing marketplaces that are out there. And I think that I'm sorry, it would be great if I could give kind of an easy answer to this, but I think that this specific question is of a nature where you just have to look at your business and your products, and then make decisions based on that.
Okay, thank you very much. There is another question about the culture. So what is the role of culture in client side in creating success when creating a digital services?
This is a super interesting question. I think that culture is kind of a lever, and when you have a strong culture that's geared towards the digitalization, and you are able to bring people on board, then you have a higher chance of succeeding. But it's the ultimate question of who really makes it in different businesses. It comes down to the product. So of course, how companies operate, it's starting to also affect how people and consumers perceive your company. So your culture might be also kind of an asset when you're selling goods, but in most cases, consumers care about the end product, and if it meets their needs, the quality expectations, the cost expectations, and it's fundamentally about are you able to deliver excellent products and services to your customers, or products and services that meet the expectations on price and quality, and what culture comes into is kind of it's a tool that has the opportunity to raise the consistency and the probability of succeeding, and it's a long-lasting thing. And I think that for example, if I look at how we see culture and how I think about culture, for example, at Reaktor, it's like that's super hard to copy, and it's and you shouldn't, but it's also it takes time to build a consistent culture, and it can be a huge asset for the company. So I think that culture, it's such a huge and it has so many levels that it's even a bit difficult to specifically put in place. I think that it plays many roles in organizations, from hiring the best talent to delivering the best products. But maybe one point that I want to take from culture is that it's sometimes seen as the culture means that you have a kind of a good feeling about everything. I think that cultures that are that succeed are also geared towards thinking about the customer, and how you deliver the results, and then the aspects of having these having a culture where you feel that you feel being part of the culture, being part of the team, being part of the company. That's kind of also there's also all these internal outcomes that come from that type of thinking. And wide question. Let's take a whole another seminar for talking about culture, and then I'll be more than happy to participate.
It's good point, and actually I will lead that to the final question, and especially from the cultural part, because our key focus here was that what can Finnish companies learn from the international companies about the digital, and especially related to a culture. So what do you think? what should we take away from the international companies?
The cultures are in very different types of stages or positions. If you look at digitalization and if you look at, for example, if you look at Amsterdam, if you look at New York, if you look at Dubai, they are all very different also in terms of how they or Helsinki and Finland, that how they think about digitalization. And I think that, for example, if you look at Dubai, it's much more fixed cost, fixed price projects, or fixed scope projects. It's the culture of buying in general is already very different, and the visual aspects of things are super important, and the talking about the technical quality and so on. It's not similar to what we see, for example, in Finland, and there are these cultural differences, and it also so cultures do play many roles also here. They affect how you sell and buy. They affect how you operate with those organizations, and within those organizations. We've also seen situations where, for example, we have had people from Finland working in US, and they are super talented technical engineers, but kind of the Finnish level of communication in general is way less than our American friends have, and sometimes we noticed in the early days that some of our people were seen as rude because they are not engaging in the small talk in a way that's expected in those cultures. So there are many things that you see there, and then we are thinking, like, how can they, like, why they see problems with this guy? He's one of our best people, and he's delivering amazing amounts of value. But it's like there you just have to meet also the cultural requirements, so to say.
All right, thank you very much, Sampo. It was so cool to have you here.
Thank you.
All right, so it's time to go on. Thank you very much for the speakers, and we are going to go for the part of the gala. So basically, what we wanted to achieve this year, well, in a nutshell, we wanted to select the best digital service from Finland. So the digital service which has been created in Finland, in Finnish companies by Finnish people, and the people who are living here. So Finnish extend that. And so why to select one? We just thought it would be kind of cool that because this association is representing the whole industry in here, and there are quite many companies. So we could say that, well, it would be really nice to select just one service which is the best this year. And we're going to award the best service, and then we are going to award some honorary mentions. And the award is this kind of a plate which is shown on the left, and the finalists are Tallink Monster Finder, the whiskey case, Macmura, VTT case, where they made this their services really simple to see in the web, and VR ticket vending machine, and then there was a Traficom to make a service 100% accessible. So these are the candidates to win the Blue Arrow Award this year. So what was the category? So how those work were assessed? They were assessed about the business results, user experience, innovation, international breakthrough, and social influence. So those were the categories where the jury gave points for the works. And the winner for this year, the best digital service from Finland 2020, Blue Arrow Award, goes for the year. Congratulations. So congratulations for the whole team. And why the jury selected this work is basically, this is a combination of many small things. And actually those all small things are working well together was the reason why this service was found very fluent, very effective, and very nice to use. And this is actually a really big step for VR compared to the old service, that how well this is working this year. So congratulations again for this work. We have honorary mentions. So basically what we tried to do, we tried to find out what is really inside there, what is really the really a good thing about the work in a final. So the first honorary awards goes to AI intelligence. So basically this is the case where the new whiskey has been blended using AI. So this is really cool way to combine a new technology to really kind of old and traditional business. So this was really a case of innovation. And I think that in the same time, this is really cool marketing campaign, because the work actually has been mentioned in Forbes, in Times, in New York Times, etc. So in many international papers. So this is really cool combination of innovation, creating a new product, using a new technology, and doing it great marketing. Then we have a Tallink bonus trip finder. And this is where we find that the end result, where kind of the bonus points which were about to be unused, were actually marketed to the customers. So the background there is that actually the front end which is shown was really simple, but the work what has happened there, for instance, in many countries in the background, is really complex. So this is combining really nicely data, marketing automation, and a really nice website. Then another mention for Trafficom. This is basically a living proof that there's a way to make website 100% accessible. And what is more, this was basically a project where the jurors saw that there are so many different parties working there, and that actually the end result is a rather simple website having really great accessibility, and that's actually something which is really hard to achieve. So another mentions goes there. And then we have VTT, and what was great in this work. The VTT is doing really complex services, so they are really hard to kind of find and understand what they really do. And in this work, actually those really complex services were made really easy to navigate. And actually the result was that the conversion in the website was much better than before. So congratulations for the winner, for the all honorary mentions. Thank you very much for the seminar, and see you next year. Hopefully we are in physical place next year, but if that's not working, then we are going to be online again. Thank you very much. Bye-bye.